Sigma summation. The sum of the terms, 10.2, 11.4, 12.1, 13.4, these are all monetary amounts represented as interest in a savings account. So such a sequence summation is called a series and is designated by S sub n, where n represents the number of terms of the sequence being added. So if you added up all 4 terms of the sequence, you would write down S sub 4. If you only add up the first 3 terms, S sub 3, and so on and so forth. Only 1 term added up, S sub 1. So here's the general case, S sub 1, S sub 2, S sub 3, all the way down. If you add up every single term in the sequence, and there are n terms in the sequence, it would be S sub n. A more compact way to write this is called summation notation or sigma notation. And we use the capital letter sigma, which is this large looking E, and it is used to indicate a sum. So when you have the sigma notation, usually you have a variable at the bottom that's assigned a value. Usually it's the first term, and it goes up to the 5th term. That means you're going to add 5 terms of this sequence, and we have to figure out what that sequence is. So we set up a table, and we take turns and we evaluate the very first value, which is 1, and 1 squared plus 2 is 3. So the first term of the sequence is 3. The second term of the sequence is 6. All the way down, 11, 18, and 27 is the last term of the sequence. And because it's sigma, we sum, or we add up all these values to get 65. Number 2, this one's a little more complicated, but it's the same process. This one starts with 1 and ends at 4. So our table looks like this. There are 4 rows. Over here, the first part of the term is -1 to a certain power. Well, -1 squared is +1. Now this part here, 1 squared plus 2 times 1 is 1 plus 2, which is 3. So the answer is +3. Now if you notice, there's going to be a pattern with pluses and minuses, because as the exponent increases by 1 every time, we're going to flip-flop between an even power and an odd power. So -1 to the 3rd power is an odd power, and it's negative. So we know that as we go down our list here, each term will flip-flop from positive to negative, positive to negative. And the sum of all these terms is -14. Now in example 3, we give you the sequence. Here's an infinite sequence, not infinite, because we know it goes up to 45. We want to add the first 45 terms of the sequence. So we want to look for a pattern based upon the position of each term. In this problem, each term is its position location times 2. For a sequence formula of a sub n equals 2n. So here it is in table form. The first term is 2, second term is 4, third term is 6. And the nth term is 2n. So therefore, sigma notation would go from the first term to the 45th term, and the sequence formula is 2n. Sage and scribe number 1. So here we see that there is a 3 on the outside. This will be handled at the very end of the problem. So let's proceed as normally. We'll start with 2 and we'll end with 4, so this will only have 3 rows. Plug the values in, evaluate, we end up with -1, 4, and 11. Add those up, and sigma equals 14. Now let's go ahead and evaluate with the 3 sigma. 3 times 14 is 42. Number 2, we need to express the sum here using sigma notation. So this is a lot like the other one with all the even numbers, 2, 4, 6, 8, up to the 45th term, but here we actually have this going up by 7s. So the sequence formula is 7n. Now the tricky part is we know that n will start with the first term, but the last term, some people make the mistake and write down it's 105. Well, 105 is the last term, but the position is actually the 15th position. And the way we figure that out is we take 105 and divide it by 7 to get 15. I want you to recall that S sub 4 means we're just adding the first 4 terms of the sequence. 2 plus 4 plus 6 plus 8 is 20. And finally, Sage and Scribe number 4, we have 1 through 4, so we have 4 rows, a minus n squared, with only the n being replaced by these values. What you'll see is you must FOIL this. A minus 1 squared gives you the trinomial a squared minus 2a plus 1. A minus 2 squared also gives you a trinomial, a squared minus 4a plus 4. So you end up with 4 trinomials, and when you add them up at the very end, you're basically combining like terms. So there's 4 a squared terms. Add these up, and the middle terms all become negative 20a, and we'll add up all the constants to get positive 30. So the answer is 4. There's the lesson. Good luck to you with summation and sigma notation.